Hello, in this C programming video, we are going to look at bitwise operators. So bitwise operators, work on a binary level, and there's a bunch of operators, and they are, pretty cool and also pretty useful. So let's go through each one of them. So let's say if we create a number, say int I equals, let's say 35. I'm also going to, in comments, put the binary equivalent. So this would be 0, 0, 0, 0. Let's have a look. Be 1, 2, no, I will get up to, can I close that down to be fair? Okay, so if you have 128, 64, 32, 16, 8, 4, 2, 1, assuming, 8 bits. 0, 0, 0, now be 1, 0, 0, 1, 1. So that's what it would be 0, 0, 1, 0, 0, 0, 1. 0, 0, 1, 0, 0, 0, 1. So that will be the binary equivalent. And let's say if I have another number, and let's say I put it as int j equals 19, and I'll put the binary equivalent for that. So we have 0, 0, 1, 0, 0, 1, 1. So it is, I'll copy that. I'll remove any spaces that need to be removed. Okie dokie, so that's what we've got. If I was to use what's called the AND operator, and this is not to be mistaken with the AND, logical operator, but the AND double amp, the single ampersand operator. What this will do, and I'll put it right here, if I put printf, and I put, and so 35, actually I'll make it a bit dynamic. So percent I equals percent I. So we're going to say I ANDed with j is equal to I and j. And I'll put brackets in here as well just so we can see it better. If I save that, let's see what we get. So we get 3. Am I thinking, what is going on? Why is it 3? So the reason is, what the AND operator does is it checks, is each one of them a 1? If it is, you'll put a 1 in the new number. If it's a 1 and a 0, or a 0 and a 1, you'll put 0. If it's both zeros, then you put 0. So this will be 0, 0, 0. So even though we got a 1 in 35, in 19 we have a 0, so it'll be 0, 0, 0, 0. Both of these are 1, so we get 1, and these are the equivalent of 1 and 2, so 1 plus 2 is 3, hence why we get 3. Okay, so that is the AND operator. Next, what we'll look at is the OR operator. So this is the binary OR operator, and you just put a single vertical pipe, like so. So with this one, what it is basically checking is, as long as there's 1 in any one of the numbers, it could be 2 1s, so 1 there and a 1 there, or it could just be a 1 and 0, or a 0 and 1, it equates to 1. So 0, 0, 1, 1, 0, 0, 1, 1. So this will be what? 32 plus 16 is 48, plus the 3 is 51. So we should get, actually now I need to save it first. I need to put backslash in as well. So yeah, there we go. We get 51. So that is the single, so that's AND operator. That's the OR operator. Next, what we're going to look at is the XOR operator, which is known as the exclusive OR operator. And what that does is it only puts a 1 if there's a single 1. So if one of these bits is on and the other one is off, then it's true. If both of the bits are off, then it's still false, so it's 0. If both the bits are on, aka 1, then it's still false because it's exclusive or. So it's 0, 0, 1, 1, 0, 0. Both of these here are on, so it'll just be 0, 0. So 32 plus 16, which is 48. And this is it's the caret symbol. On my keyboard, it's Shift 6. It might be different on your keyboard. This is the XOR operator, also known as the exclusive OR. There we go, 48. Next one we are going to look at is the ones complement operator. So the ones complement operator, if let's say we do it with this one here, the ones complement, it just flips the bytes, flips the bits. So 0 becomes a 1, 1 becomes a 0, 0 becomes a 1, 1 becomes a 0, and this is the ones complement operator. Yeah, there we go. It's the tilde symbol that we want. Again, depending on your keyboard and where it might be in a slightly different place. And we'll just do it on a single number. You could do it on a result, but like I said, we'll just do it on a single number, and we've done it for J. We'll do that. So I can get rid of this. Put the tilde, and I can get rid of this, and I'll just say, yeah, centi tilde equals centi, and I'll put regular J as well. And so if this gets odd, we get 128 plus 64, which is 192, plus 32, which is what, 228. 228 plus 16 is 244. No, that's not 16, 8421, sorry. So 128 plus 64 plus 32 is what, 224, 232, 236. I'm saying we should get 236 as the result. My maths is on point. We get negative 20. Think about this. Ah, I see what's happened. Oh, yes, 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 yes. So, what it done? Let me think about it. Hmm, yes. So, what it actually does is it starts at, you know, it flips this one. So, this is basically negative 128. And then it kind of just, well, adds the values to them. So, it's add 64, add 32. We got, negative 34 left, and 8 and 4. Let's have a look. No, 128 plus 64, which is what? 64 plus 32 is 32. Yes, negative 20. Yeah, that's working as expected. That was a little mistake on my part. But yeah, that's okay. So that's the ones complement operator. Next, we're going to look at look at the binary left shift operator. Again, we'll do it on a single number. So let's say we do it with this one. And what this does is, so it moves it by X amount of spaces to the left. So if I was to move it one over, it'd be 0, 0, 1, 0, 1, 1, and anywhere there wasn't a bit anymore, it just becomes a 0. And this is the left shift operator, like so. And to do this, put the number or the value less than, and then let's see, put 1 in how many shifts you want to do. And then we'll do the other way as well, is greater than, and this is saying we're going to shift it to the right, and we're going to shift it by 1 as well. And we'll do a shift there, and I will copy and paste this. This should be a right shift. So it's 0, 0, 0, 0, 1, 0, 0, 1, and anything that goes over is lost. So that's it. So if we save that, this should give us what, 128, 64, 32 plus 12, which is 34, and this should now give us, so what, 8, that should give us a 9. Save that, so we should get 34 and 9 at the bottom now, instead of, well, our number of 19. So we got 9, we got 38, so let me make sure I've got this correctly. 38, 32, plus 8, no, plus 8, plus 4, and plus 2, plus 6, 38. Yes, that is correct. That was just a bit of mistake on my part, but yeah, that's the bitwise operators. You have the AND operator, which checks are both bits on. The OR operator checks is any bit on. The XOR operator, known as the exclusive OR operator, it checks basically, is only one bit on, and that's it. One's complement basically has the effect of flipping the bits. Left shift and right shift operator moves it either to the left or right by X amount. So I've chosen 1. You could choose 2, 3, or however many bits places you want. So those are the bitwise operators. If you have any questions, feel free to pop me a message on the Discord group. There'll be a link in the description. And as usual, I'll look forward to seeing you in the next video.